All right, using your calculator, I want you to fill in these boxes. What's 10 to the 4, 10 to the 3, etc., all the way down to 10 to the negative 4. And don't go with what you think the answer might be. Please do use your calculator. And then I want you to fill out these ones here, and I want you to fill out these ones here. So just pause the video right now and then fill in your answers. So one of the things that we had already talked about in this unit was if we notice anything to the exponent of 0 is 1, look at the patterns. We're dividing by 10 each time. We're dividing by 2 each time. We're dividing by 3 each time. That's related to the base. So the next thing that's a little bit more challenging then is how do we do the negative exponents? When you punched into your calculator, you probably got 0.1. But 0.1 as a fraction is 1/10. So I do want you to write these as fractions. And this one was probably 0.01, but as a fraction, that's 1 over 100. Notice the pattern. We're 1 over 10, 1 over 100. The next one will be 1 over 1,000, and the next one will be 1 over 10,000. Likewise here, you probably got 0.5, but I want you to write it as a fraction, so that's 1/2. Then you probably got 0.25, but as a fraction, that's 1/4. Again, notice the pattern. So the next one will be 1 over 8, and the next one will be 1 over 16. This one, as a decimal, you probably got 0.333333, but as a fraction, that's 1/3. If we follow these same patterns, the next one then will be 1/9, the next one will be 1/27, and the last one will be 1 over 81. So what I want you to do now is look at the table. I want you to ask yourself, how do you think you could write this as a positive exponent? So some of the answers could be 0.1 to the 1, and that's correct, but I want you to keep the fraction. So how can you write 1 over 10 using exponents and using exponents that are positive? Well, you could write it as 1 over 10 to the 1. The next one then, you could probably write, if you wanted, as 0.01 to the 1, yes. You could also write it as 1 over 100 to the 1, but notice that my base is 10. So I want to keep the 10. So I could write it as 1 over 10 to the 2. The next one then would be 1 over 10 to the exponent of 3, and finally 1 over 10 to the exponent of 4. So if we continue that pattern, we're going to notice, how do I write 1/2? Well, I can write it as 1 over 2 to the 1. And then I can write it as 1 over 2 to the 2. And 1 over 2 to the 3. And 1 over 2 to the 4. Remember, math is all about patterns and looking for patterns in relationships. So let's use that for this last column. Again, I can write it as 1 over 3 to the 1, 1 over 3 to the 2, 1 over 3 to the 3, and 1 over 3 to the 4. So at this point, I want you to check your chart to my chart. See if they're the same. What we now see is it says, what do the patterns tell you about 0 as an exponent? Well, if we look, all of the rows with 0 are equal to 1. So when the exponent is 0, your answer always equals 1. So now, we probably don't need our calculator. What would 4 to the 0 be? Well, it's 1. And 25 to the 0 is 1. And 129 to the 0 is 1. And 0.001 to the 0 is 1. So any number, so we could say x to the 0, any number to the exponent of 0 is 1. And you learned that last year. We're just kind of reviewing it. A little bit trickier now. We're going to look at what's happening with the negative exponents. So again, maybe pause the video for a second. Look at your table. Look at the negative exponents. And maybe write down a few things that you notice. So take a second, pause it, write down a few things you notice, and then restart. So probably one of the things you might have noticed is that they're all fraction answers. And probably another thing that kind of might have thrown you off a little bit is that there's no negative answers. So that's another thing that's really interesting to think about. So the next question asks you to try to write your fractions, write your powers with a positive exponent. If we look up here in the chart, it said 10 to the negative 1, and then we made it 1 over 10 to the positive 1. Or it said 10 to the negative 2, and we made it 1 over 10 to the 2. So what you have to ask yourself is, what were we doing there? How did we make those exponents positive? So what do you think you would do for 4 to the negative 1? When you compare to what we did in the chart, we just basically returned them into fractions. So could we do 1 over 4 to the positive 1? Then if we evaluated that, if we thought, what is 4 to the 1? 4 to the 1 is 4. We would get 1 over 4. Well, let's try it for the next one. If 2 to the negative 2 was 1 over 2 to the positive 2, what do you think 5 to the negative 2 would be? Is it 1 over 5 to the positive 2? To evaluate this, again, we don't really need our calculator. We just think, what would that be? Well, 5 squared is 25. That would be 1 over 25. In fact, I don't really want you to rely on your calculator. Most of you, if you punch this into your calculator, most of you are going to get decimal answers. So it's perfectly fine to punch into your calculator what 5 squared is if you don't know what 5 squared is. But don't punch 5 to the negative 2 into your calculator, because it's going to most likely give you a decimal answer. And I want you to be using your brain. I want you to rely on your brain to get the answers, not on your calculator. So the next one we could write as 1 over 4 to the positive 3. And that would be 1 over 64. So again, if you don't know what 4 to the 3 is, figure out that that's 64. Don't punch 4 to the negative 3 into your calculator. This one would be 1 over 2 to the 5. And 2 to the 5 is 32, so that would be 1 over 32. The last one's a little bit trickier. What I want you to do is look at, we went from 4 to 1 over 4. We went from 5 to 1 over 5, or from 2 to 1 over 2. I want you to think about what the relationship is between 4 and 1 over 4, and 5 and 1 over 5. So what these actually are is reciprocals. The reciprocal of 4 is 1 over 4. And the reciprocal of 5 is 1 over 5. So if we were to look at this last one, to make the exponent positive, we're going to do the reciprocals. So we're going to make it 3 over 2 to the positive 1. And then we'll evaluate that. And I know that's a tricky one. And you will have an opportunity to ask questions about this. But just let it all sink in. If you need to pause or you need to go back and listen to some of this again, please go ahead and do so. So if you had to make a conclusion then, what's happening with these negative exponents? Well, if we use the reciprocal of the base, if we take what the base was and use the reciprocal, it makes the exponent positive. Once the exponent is positive, then we can evaluate it. So again, I know that's probably challenging. Let that sink in. So when we look at a negative exponent, we don't just punch it into our calculator. We have to do a little bit of work. Step 1, we have to make the exponent positive. How do we make the exponent positive? We take the reciprocal of the base. Step 2, then we evaluate. So this is step 1, make exponent positive, and what we're doing here is the reciprocal. That's important. Step 2, evaluate. So let's complete these rules. So anything to the exponent of 0 is 1. This one's a little weird. It just says any number to the negative of some other number. Well, what do we have to do? We have to do the reciprocal. So we write 1 over a, and what that does is it makes the exponent positive. This last one, again, we do the reciprocal, so it becomes b over a, and that allows us to make the exponent positive. So I want you to try these last few, and I want you to think about what they might equal. So this one's going to be 1 over 2 to the 3, and I'm out of space, I can't go lower, so I want you to write your equal sign underneath. I'll have to write the cross. That's 1 over 8. This one is 1 over 6 squared, which is 1 over 36. This one's 1 over 4 to the 3, which is 1 over 64. This one's a little bit trickier. Remember, reciprocal, so it becomes 2 over 1 cubed, which becomes 8, or 8 over 1, that's fine as well. And this one, we do the reciprocal. Then we evaluate. Remember, that means 3 over 2 times 3 over 2, and that will be 9 over 4. So I want you to let all of this sink in. It is a challenging concept. You will have an opportunity to ask questions. Maybe write down some of the questions you might have. If you need to go back and re-listen to some of this, please do so.